In this video, we're going to create and use an exponential function to model a situation. I'm going to use several different tools here to show you how you can do this with this problem. Let's first talk about what the equation will be for this model, since it's an exponential growth model for population growth. The initial quantity Q naught or Q sub 0 given here is 40,000. And then we need to add 1 to the growth rate of 3.5%. So that makes us 1.035. And we're going to raise that to the t power. Now you're going to see that I already have a Excel sheet set up here. I'm going to type this equation in here. So 40,000 times, and then in parentheses here, 0.035 raised to the, and my variable is going to be the year here, t. So I'm going to raise that to the t power. And then I'm going to drag this down. I've already set my column up here to it's not right. 40,000 times 1.05. 1.035. There we go. And so this is, I've already set this up to be whole numbers here. So you may need to adjust your column to round for you, but that's going to be 41,400, then 42,849, then 45,901, then 47,000. Sorry, I missed one. 44,349, then 45,901, then 47,507, then 49,170, 50,000, 891, 52,000, 672, 54,516, and 56,424. Now let me just show you a couple other tools that are available to you here to help you if you have a TI-84 or 83 calculator. You can go into y equals. We can write this as 40,000 times 1.035 raised to the x. Make sure your table settings are set on auto for your independent variable here, and go to your table, and 0 through 10 are right there. 40,000, 41,400, 42,849, 44,348.7 is going to round up to 44,349. 45,900.9 is going to round up to 45,901. 47,507.4 is going to round down to 47,507. 49,170.2 is going to round down to 49,170. 50,891.1 is going to round down to 50,891. 52,672.3 is going to round down to 52,672. 54,515.8 is going to round up to 54,516, and 56,423.9 is going to round up to 56,424. I also could set my calculator and my mode to only go to 0 decimal places here, whole numbers, and then the table would have it's not going to round for me. It doesn't round on the table. So, but if I was going to do any calculations out on the home screen, it would round them for me. So there we go. One other tool that's available for you, if you don't have the TI-8384 calculator series here, is going to be Desmos, the graphing calculator here. And we can just call this y equals 40,000 times, and then 1.035 to the x. And we want to convert this to a table here. We want 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And you'll get the same values that we got from the graphing calculator, and you can round those appropriately. Now, what you're also going to get from Desmos here, if I zoom out, is you're going to get the graph. I also am going to get this from my graphing calculator. The window here is from 0 to 10. So we want to zoom out here from 0 to 10 and start at 40,000. So 40,000 is way up here. Let me just use my graphing calculator to help me with this. So window is going to go 0 to 10 by ones, and then window Y max is going to go 40, Y min is 40,000, Y max is 70,000, and my scale looks like 10,000s on Y, because there's a 30,000 gap between 70,000 and 40,000, and there's 3 tick marks there. So let's graph that and see that it looks like that. So it's increasing, and is it increasing at an increasing rate, or is it increasing at a decreasing rate? Should be increasing at an increasing rate here because of exponential growth. It should be curved like that, not like this. So that's going to be A. And that's it for this video. We can get the graph and the table, both from our graphing calculator and from Desmos and from Excel. Excel is just a little harder to do graphing on, but we can do that too. So we'll come back next time, and we'll keep talking about Unit 9C. See you for the next video.